We are in the Mobile World Congress 2018 and we are in the booth of Hewlett-Packard Enterprise, and we are in front of the replica of the actual Discover who went to space already. It's in the International Space Station for 164 days, where we are doing some testing with some demos and stuff, so that in 2030 we can actually send people to Mars. So the idea is that we will, you need to take decisions on the spot, because if you take the information in the space station, send it back to Earth, process it and send it back, then that would be way too long, and then if there is an urgency, you wouldn't have time to react. So then what we're doing here is to try to take decisions on the spot, on the ship itself, so that we can safely or safer send people to Mars. And this is an exact replica of the actual Discover. We're using a server. It's a normal server, like a powerful one, but a server that will give the intelligence to the ship. So it's a server like that one, like that white box there.
What kind of communications, 5G or something like that?
No, in this case we're trying to provide like all in the ship, because it's too far. You wouldn't have chance to send it back, at least not in time.
Do you have data from the astronaut that is already on Mars?
So far it's going well. Like, that's everything I can say. We're taking it daily, we're pursuing it, and so far all the tests and it's surviving well in space, let's say. And so far that's everything I can say is going well.
How long it will be the trip?
1 year. Actually, we're testing it for a year in space, because it will take a year to go to Mars.
And do you think people are going to travel to Mars?
Well, I hope so. I would like to, but at some point.
What we are doing is we are working with NASA to provide computational power to enable their scientists, doctors, geologists, the tools they need when they get to Mars.
How exactly?
So one of the things that we're doing is we're providing large performant computers, and we're using the same computers as these scientists use on Earth. So there's no specialist hardware, there's no specialist tools. It enables the scientists to take equipment and tools that they know and use them in space. Now, there are problems with that. Typically, space hardware is hardened. It's expensive, it's timely and costly. Now, I know expensive and costly are the same things, but it's so important I thought I'd say it twice. So what we're trying to do is we're trying to take commercial, off-the-shelf servers, put them into space, and run management and system software over it to ensure that it continues to run. So it's fully autonomous. This enables commercial servers to continue to run and deal with errors that naturally occur. Now, within space, you're going to see higher levels of radiation, possibly greater instances of failure, and so therefore having autonomous systems saves the problem of having people interacting with computers. The other benefit it brings is it means you don't have to send data back to Earth, which is a big problem when you get to Mars. It enables you to send information by providing more computational power to provide insight as opposed to data. The servers are currently in the International Space Station. They were launched on the CRS mission on August the 14th, which was done by SpaceX. The two servers arrived at the ISS, and then about 30 days later they were powered on. So currently, as of today, the 26th of February, they've been up in space 194 days and have been running. So the system uptime, they've actually been running for 164 days. So nearly halfway through their 1-year mission.
Any technical details that you can provide us?
They are perfectly standard 1U 2-socket Xeon servers. They're linked with InfiniBand. There's a pair of Ethernet switches in the back, redundant power, redundant switches. But apart from that, they are completely off-the-shelf servers. Nothing special about them. The communication with the spaceborne computer is purely an informational exchange. So every 5 seconds we provide an update using dedicated links. There is no commercially available mechanism that public can get at data from the space station. All there is dedicated links, and NASA determine what is made available. This is a NASA project that we are working with. We have a very good relationship with NASA. We supply NASA's Pleiades machine, one of the largest supercomputers on the Earth. We've had a long relationship with them. It's been very fruitful, and this is an opportunity for us to work together to try and show progress in a different way. I think the fundamental difference is that governments, NASA, spends money trying to prevent failures. In the commercial world with very, very large supercomputers, we try and spend money managing failures. Nobody would buy a space-hardened supercomputer for Earth.